Audio Jungle. Audio Jungle.
We have the characteristics equation. Characteristic. This characteristics equation basically we are talking for the say, dynamic. So basically we'll talk about the for the characteristics equation we'll able to find the eigenvalue. Correct. I will write here. Thought. Okay. The solution of of CE characteristics equation. Characteristics CE solution of CE characteristics equation yields the eigenvalue. This is the eigenvalues. Eigenvalue that is nothing but delta. Sorry, lambda. Now think about it. This eigenvalue maybe eigenvalues we are getting maybe uh, imaginary, maybe real, uh, maybe complex. Complex in the sense obviously it's we are talking about the real and real part both. So if it is happening, then what type of the motion will be there? That is the main, because single marks question they are asking from here. So you just make a proper notes carefully. So here basically we are going to talk that eigenvalue. We are going to talk types of eigenvalue. It's nothing but the real, okay, real eigenvalue, and we have a complex eigenvalue. Remember, if we are talking about the real and complex eigenvalues, so actually, in general, in general, we'll be talking the p plus iq, p plus iq. P is nothing but real number here, and q is nothing, you know very well, complex, imaginary. In complex, you know, this is what complex, right? So we have that eigenvalues real. It can be p1, p2, p3. These are the real eigenvalue. Q will be the imaginary. So complex eigenvalue. So basically in complex both real and imaginary both will be there. Real eigenvalue means p term will be there as per this p plus iq, that is nothing but z. That is nothing but z. Generally z is nothing but x plus iy, where x is nothing but p and y is nothing but q. Okay. That is the idea. Now just listen carefully. One by one you just make a note of it. It's very special, important for make a note. If case 1, case 1, what is the case 1? If eigenvalue, from where you will get eigenvalue? From the characteristics. That characteristics equation will be given to you, or if it is not given, then data will be given to you. With the help of that characteristic you have to develop, and from you have to solve that characteristics equation, then ultimately you will get the eigenvalue, you have to solve that characteristic with the eigenvalue, and that eigenvalue, if eigenvalue is real. Real means no imaginary part. If it is real, then what will happen? Think, you have to say associated with, associated with non-oscillatory, non-oscillatory, non-oscillatory motion. And here also you have to write having having a damping rate, having a damping rate equal to equal to negative of eigenvalue, equal to eigen, right? Number one. Number two, if, take it, if the same only, if a real eigenvalue is zero, think about it. If a real eigenvalue is zero, zero, the solution corresponds to rigid body mode. Rigid body mode. Next, this is point one, and we have a next point. If real eigenvalue, real eigenvalue is negative, is negative, the solution the solution corresponds to a convergent mode. Hope you remember convergent mode. Last class I had convergent mode, describing an exponential return equilibrium after disturbance. Here I have to mention right here also, put describing a simple rigid body displacement. rigid body. Okay. Now, third I have given. Then we'll talk about the fourth. If real value is positive, the solution responds to divergent mode. Divergent mode describing describing an exponential deviation deviation from equilibrium. This is the one thing you need to remember, but I just want to summarize this. I have told you that is x plus iy, or the complex variable p plus iq. This p is nothing but real. P is nothing but real. Now, for the real eigenvalue, actually this is nothing but the complex, but in the real eigenvalue, if you talk, complex means real and imaginary both. So P is nothing but real. So this P will have a two possibility, three possibility. Check. P is zero, P is positive, P is negative. Correct? That means a real eigenvalue will have two possibilities: is zero, or it is positive or negative. So if it is zero, then the behavior will be rigid body. The behavior will be a rigid body. Here will be rigid body, and obviously, if it is rigid body, so that it will be describing by a simple rigid body displacement, just like in solid structure. When it is happening, when it is rigid body, okay? When it is rigid body, and if this basically this is in complex, I'm talking the real eigenvalue, okay? But at the same time, the real eigenvalue, if it is the purely purely real, that means no complex, then the purely real eigenvalue was always associated with the oscillatory mode, oscillatory, non-oscillatory, non-oscillatory. When it is purely real, but once it is complex, then obviously it will not be not non-oscillatory. It will be oscillatory. Complex, then it will not be a non-oscillatory. It will be oscillatory mode. Will be oscillatory mode. Now, so how? Anyway, so if it is purely real eigenvalue, then it is non-oscillatory. Right. Now, eigenvalue is purely real. Huh? Eigenvalue is purely real. Then it will be non-oscillatory mode, and that I have told you, if it is purely real, I have to say Q is the purely real plus I should say I zero. There is no Q. Means Q is the imaginary which is zero. It becomes a purely real eigenvalue. Please listen carefully. So in this situation, I have told this will have a three possibility. Please make a note of all three. Less than zero means negative. Now, if it is, then it will behave like a rigid body, just like a solid body would. Rigid body, and this will be p greater than zero. That means if a real eigenvalue, if it is positive, then what will happen? Then it will be a divergent mode. Okay? It will be a divergent mode. Divergent mode. Just like see, still it is a non-oscillatory. Okay? It is a non-oscillatory because we are talking a pure real. Still it is a non-oscillatory, but in non-oscillatory also there will be a divergent, there will be a convergent. Divergent means without any oscillation it will go away from equilibrium, and convergent means it comes to equilibrium but without any oscillation. I have shown last all three dead beat, convergent, divergent, all three I have shown you, right? So you know that. So if p is less than 0 means the real eigenvalue, if it is negative less than 0, then it will be convergent. Be convergent. Okay. Convergent. This is in case of negative, case of positive. It is very important. Please remember. Right. Now, how it is coming back, that also it is clearly mentioned. Divergent mode will be there, but exponentially. Convergent mode, it comes to the equilibrium, but what path it will follow? It will follow exponential path. If it is asked to you in examination, one exam was asked, but this is also related to vibration only. So it should come to its initial convergent mean it should come. That amplitude should be zero, but without any oscillation. So convergent mode means it should come to initial condition, but without any oscillation. So what path it will follow? It will follow the exponential path. So it will follow the exponential path, even though convergent and divergent both. Okay, this is the when the eigenvalue is what real. This is very important here. Okay, now coming to the very important what we want to discuss here. That is nothing but the case two. What is the case two? Check. The case two is nothing but if if eigenvalue is complex. If eigenvalue is what? Complex. Complex means same. Z is equal to x plus iy. There x is nothing but real. Here you are denoting by p, and I imaginary symbol, y is nothing but q. Here p and q both are not zero. P and q. In previous case q was zero. So pure eigenvalue was there. Okay. Here q is also there, means real and imaginary both are there. That's the reason it is called complex. Huh? So if eigenvalue is what complex, so complex pair of eigenvalue is what associated with the oscillatory mode, that already it was derived in vibration. If you had seen cos e to power I theta, e to power I theta means cos theta plus I sin. Cos theta plus I sin, what it indicates is the real and imaginary. So only the complex roots will give the oscillatory mode. Okay, the complex root will give the oscillatory mode. Right now, you need to remember this. I have to write all three cases one by one. The a complex pair. Okay, please remember this. Complex complex pair of eigenvalue of eigenvalue. Complex pair of eigenvalue. Complex pair of eigenvalue is associated is associated is associated with associated with oscillatory mode. The oscillatory means whenever they, and you know the complex pair means what, z is equal to x I plus minus I y. If you remember, this is called a conjugate. So if you talk z1, it will be x plus I y, and if you talk z2, it's nothing but x minus. Remember this z1 and z2 conjugates rule, correct? That's the mean of it, complex pair. So if you say complex pair, so complex pair means what? Both positive and negative. It's all numerical also. You'll understand. Don't. But here I'm just taking one by just background only. You will understand this thing, whole thing, when I will solve problem more clear to you. Right. Having a damping rate, having a damping rate equal to the this, why I'm giving this line, I mean statement, because if you see the root and if you remember this statement, then you can identify that what is the damping rate. So that will nothing but equal to the negative, equal to unit, right, equal to the negative equal to the negative of the real part, of the real part part of eigenvalue of of eigenvalue, correct, eigenvalue, and a damped natural frequency frequency equal to equal to the imaginary part. I will write here in, you will understand, imaginary part eigen. Okay, this is the point one. I don't know how many of you remember that we had written that eigenvalue we had. I mean, there was the roots we had written. There was the roots. So how you will write the eigenvalue? Think about it. Just say I'm writing a lambda here. Will be nothing but zeta plus I wn. Just think like this. It will be written. It will be written like this. So zeta in the previous whatever I have explained you. So in this situation, that damping rate equal to the negative part. So this zeta will be, it will be somewhat like this, minus p of iq, something like this. It will be given. So that zeta is nothing but, check the previous what I have given, that damping rate, that damping rate equal to the negative of real part of eigenvalue, and damped natural frequency equal to the imaginary part of the. So this is the one example. Through the example I am explaining, but don't worry, I will be solving numerical WD, damped natural WD. But you know WD is nothing but Wn root of 1 minus. Anyway, we'll solve problems so you will understand. So zeta is nothing but the uh, real part minus p, and the WD will be imaginary part, which is, that's the mean of it. Whatever the statement you have written, this is the mean actually. Roots will be given to you, lambda 1 comma 2 plus minus will be given to you, like that roots will be given to you. So you have to find where is the damping rate and where is the damped natural frequency. Okay. Oh, that is the one point you got here. And this is the one when uh, when the roots are the complex. Okay. Now the first point you have written here. This is the first point you have written. Now coming to the written, right? I have written the negative equal to the negative a2 of a2 of the real part, real part, real part of the eigenvalue, and damped natural frequency, damped natural equal to imaginary part of the imaginary part of eigenvalue. This I have. So what is the second point when the roots or eigenvalue is complex? Then what is the second point for this? That also you need to write. If a real if a real part of the real part of the eigenvalue is 0, value is 0, the solution corresponds undamped mode. Undamped mode describing describing sinusoidal motion. Sinusoidal motion having constant amplitude. Meaning is very clear. Check example. If that is the lambda in our case, if it is nothing but x plus iy, in our case it is p plus I. So if we have p is 0, 2 plus iq, means pure imaginary. Pure imaginary, correct? Pure imaginary. If it is pure imaginary, then what type of oscillation you will have? Undamped mode. Undamped, undamped mode, and undamped mode will be there, but it will follow the sinusoidal. Remember earlier when there was the pure or pure real, you can say. So there was the, even though it was undamped, but exponential path was followed. But here sinusoidal motion will be there. Sinusoidal would, but there will be a constant amplitude. Constant, somewhat like this. See, like something like this. Amplitude constant is undamped. Undamped. Damped means what? That amplitude should decrease. That is the damping. But here, even though it is oscillating, oscillation is there, but undamped. Will follow the sinusoid. Again, it will not comes to equilibrium. Yes or no? Why? Because it is not going to back to initial condition. It will be oscillating. It will be oscillating, but undamped oscillation is not going to reduce the amplitude. You all understand. So this is the very important part. Whatever I have explained. Okay. Now, if you, as I have shown you the till now for the longitudinal dynamic stability, I have discussed two type of oscillation: short period uh, oscillation and long period oscillation. Long period oscillation, it will explain phygoid mode or phygoid motion. So I will discuss first here for the longitude. Okay, so let me write for longitude dynamic stability for LDS, for longitudinal dynamic stability. Longitudinal, longitudinal dynamic stability. I have told you last class only I had explained. dynamic There was the short period oscillation, short period oscillation, SPO, and and long period oscillation, long period oscillation, SPO, LPO, long period oscillation, SPO, short period oscillation. This LPO, long period oscillation, also called as a phygoid motion, PM, phygoid motion, phygoid, phygoid, phygoid motion, also called PM, phygoid motion. Okay, so now think about it. What will be happening to the SPO and LPO in terms of the eigenvalue? This is very important for numerical point. So if it is a short period mode, then eigenvalue having the magnitude, uh, basically largest imaginary part, magnitude will always correspond to the short period oscillation. Short period oscillation. So whatever the uh, that eigenvalue you will have, the you can say the largest magnitude or largest imaginary part, largest imaginary, largest imaginary, largest image part magnitude magnitude will magnitude always correspond corresponds to SPU, largest imaginary part. There will be a real part, there will be a imaginary part. That imaginary part, the largest, will do the SPO, that short period oscillation. Why it is, I will explain. Now coming to the LPU, coming to the LPU. So for the LPU, as you know very well, for the LPU, for the LPU, long period oscillation, the second largest eigenvalue pair, or smallest imaginary part magnitude always. That the largest imaginary value, the largest imaginary value will give the short period oscillation, and the smallest imaginary part magnitude will always correspond to long period. So always remember, always remember, I have to write the smallest imaginary part. Just imaginary imaginary part magnitude will always corresponds to corresponds to LPU, correspond LPU or PM, forward motion, or forward motion. Always remember, if we talk about the rigid body mode, so rigid body mode basically it's related to the steady state condition of the aircraft. It's a trivial rigid body mode. It states that steady level flight. Steady level flight is called a rigid body. Anyway, so this I have explained you. So largest imaginary part magnitude, and the smallest imaginary part. I have to write here smallest imaginary part of the magnitude, and this is the largest magnitude. You need to remember this part. It's very important actually. Very important. Now we'll see, because last class I had explained you what is the short period oscillation, uh, uh, long period oscillation. That part is what done, and long period oscillation, that is the figured motion. For the figured motion, I have the formula also. I have derived actually. I had shown the time period as well as naturality, and also I had damping factor or damping ratio for the figured motion. Remember, that is very very important for now. Still, will be writing here Routh discriminant. And okay, so basically this is the one method uh, has been developed, has developed Routh. So he's a mathematician actually. He has given a solution for the dynamic stability or dynamic characteristics equation. For the dynamic characteristic equation, how we will get the solution? We'll follow the Routh discriminant method. So anyway, you just see. So basically, suppose the characteristic equation, characteristics equation. Here you see characteristic equation for the stability characteristic. Here it is given. Check. So this is the one characteristic. Think about it. a lambda to power 4 plus b lambda to power 3 plus c lambda square plus c lambda. Check. This is the one characteristics equation for the dynamic stability. The dynamic stability, the equation for longitudinal, and for that this is the characteristics equation. So obviously this characteristics equation, if you check, the power 4 is given. If you find the root, so how many roots? Get 4. So that will be considered as a that eigenvalue for the solution of the characteristic eigenvalue. Okay. Now coming to the to check what type of longitudinal dynamic is. It is, I mean, SPO or it is LPO, that we have to check with the help of this Routh discriminant. Okay. If you check here, is ABCD. If you check ABC, ABCD are constant. And they are constant here. They are constant. One thing is very important for all the roots, all the constant. Okay, so all the, I will write here one by one. You please remember this. This will be very helpful. Remember, to check the longitudinal dynamic stabilization, few points are very important. Points are here. So you just remember all the coefficient like A, B, C, D. These are the constant. Okay, these are the constant. So all the coefficients, all the coefficients should be positive. Positive. Number one. Number two. Number two. B and B and C, okay, should be should be greater than and E. Check it. B and C. This is B and C. It should be greater than E and E. Okay? And the third is nothing. Okay? The third is nothing. A should be almost. A should be almost or equal to, almost or exactly equal to equal to one. Which one? Here we are talking this Routh discriminant for the longitudinal dynamics. For what we are talking longitude, LDS. Okay, longitudinal dynamic. Okay, now you think it here. We'll discuss all the uh, condition, because here we have to talk the Routh criteria first. So to talk Routh criteria, so definitely the Routh constant. So you have Routh criteria. Check it. This is very important. Routh Routh criteria, and you see R. R is nothing. Routh constant. Okay, R is nothing but Routh constant. So R is nothing but B C E, okay, minus is the mathematical model, okay, has been given out. E square minus E square E. Take it. Now you have to see all the uh, analysis completely based on the Routh's constant one. Routh's constant only, that is R. Okay. So first of all, this will be the characteristics equation. Okay. This will. So now we'll talk about the Routh's constant first. So we'll write here case one. Case one. Case one. Suppose the Routh's constant capital R. Capital R is equal to 0. Routh constant capital R is equal to 0. What will happen? What is the mean of it? Huh? So you just write down. The meaning of this is nothing but represents represents dynamic dynamic neutral condition. Dynamics neutral condition. I mean, one type of question they can ask, they can give the characteristics equation, but there you don't have to calculate the roots and all. Not required. Simply they will ask, it is the figured motion, or it is short period oscillation, or it is dynamic neutral condition, it is dynamic stable condition, or dynamic unstable condition. Such type of question. So that time, from the characteristics equation, A B C D E, that is the constant, will be given to you in characteristics equation. Just compare and find out A B C D, and from there you calculate the Routh's constant. If you check Routh constant capital R is equal to 0, then you will say yes, it is the dynamic neutral stability or dynamic neutral condition. I hope you understood my point. Correct. Now, second we'll talk case 2. That Routh's Routh's constant, that is capital R. Now it is going to be, suppose uh first it was 0, then can say less than 0. Then what will happen? So you just write down points you need to remember. Okay, in examination question will be asked from here. So it represents, okay, represents dynamic unstable condition. Dynamic unstable. Dynamic unstable. Okay? Always remember. Uh, One thing. Second thing, it is the dynamic unstable. That is clear. Okay, it's clear. Dynamic unstable. But in if it is dynamic unstable also, then what about the uh, roots? I mean, if even though it is a dynamic unstable, so if the roots are there, then through the roots, how you will find it is figured or short period. So that for that reason, I will write second point. Second point, roots having. Okay, in this case, I will write in this case, one of the roots. अरे पढ़ा लेना बाद में यार, क्यों रिकॉर्डिंग खराब कर रहे हो? In case of one of the roots having complex pair. having complex pair with 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 positive real part, positive real part represents real part represents represents undamped oscillation, undamped oscillation. Okay, remember it. Roots having complex pair, I mean, you will have a four roots, right? So at least one root you will get, at least one root you will get a complex pair. So if one roots one roots of complex pair with positive real part, represents undamped oscillation, undamped oscillation. And third point, other pair, total four roots we have, right? So one roots, that is nothing but complex. So that complex pair, that positive real part represents undamped oscillation, and other how many pairs you have? Other three. There three roots are there. So I have to write other pair represents a phagoid, okay, long period oscillation LPO or SPO, short period oscillation SPO. Because LPO and SPO, it is the basically damped oscillation. See the long period oscillation, it's a damped oscillation. So other means one root which is complex, so that positive real parts represents undamped oscillation, but other pair represents LPO or SPO. Okay. That is the one condition you got when the Raoult's constant R, which is less than zero. Less than zero means when it is negative. That time I'm talking. When Raoult constant, and how you will find the Raoult constant? You will find the Raoult constant with the help of this formula. You need to remember. This is the formula. With the help of this, you will find the Raoult constant. Raoult constant, it is zero. Then for that case, I have given this case 2. Case 2. Now we'll be talking case 3. Case 3. Take it. Huh? So here Raoult constant R. Here I am writing R is nothing but greater than 0. R is 0. That means R greater than 0 means it's nothing but positive. Listen, it is very important actually. So this will, point 1, if Raoult's constant you are getting positive, that means it is dynamic stable. It represents dynamic stable. Very important. Check if Raoult constant is negative, less than 0, it is first only it comes down dynamic unstable. So direct question can be asked to you. They will give the characteristics equation. Simply they will ask this characteristics equation represents dynamic stable, dynamic unstable, or dynamic neutral. So for that, what you will do? Simply you just calculate the Raoult constant. How you will get the Raoult constant? You just use this formula. Here we have that from the characteristics equation, you will find the A, B, C, and once you get the A, B, C, D, E, just calculate this. Use this formula: B, C, D minus D square A minus B square E. Use this formula and find R. If your R is what? Positive. Okay. is 3. If R is what positive, that means it represents a dynamic stable condition. I hope you understood. And see, this is again very important. All the modes are periodic and damped. All the modes, all the modes are modes are periodic, and you should know periodic and aperiodic. Aperiodic means non-oscillating, and undamped. Undamped also a non-oscillatory. Uh, but periodic means it's oscillatory, and damped. Damped oscillation is always a stable oscillation. Okay, so all the modes are periodic, damped. That also can be asked to you in examination. They can ask like which one this equation, characteristics equation, shows the periodic, aperiodic, damped, undamped oscillation, kind of things they can ask to you. So please remember this. All the modes are periodic and damped. One day I had explained modes, types of the motion along the axis. The third is very important. Generally has two modes. Generally has two modes. Modes phygoid and short period oscillation. Two modes. What are that? Long period oscillation LPO, that is the phygoid, and SPO, short period oscillation. Long period means phygoid. Okay, always remember, that should not be PM, phygoid motion. Okay, always remember. And the fourth is very important. Please make a note of it. The roots of characteristics equation. Check. Roots of characteristics equation will be complex. There will be complex pair with negative real part. With real part. I will show the example how it will be. So they said if you check for the r greater than 0 condition, which is the stable, so you see the roots. That roots should be roots of characteristic equation will be a complex pair. Complex pair means conjugates, but it will have a negative real part. Means I will show you maybe minus of, check it, that roots will be something like this. See, minus of E1 plus minus I Q1. This is the one root, and another roots, because the roots should be in pair. So another roots will be minus of P2 plus minus I. Check both real parts are negative. So if you see something like this, then directly by seeing the roots only you can say, okay, this is dynamic stable, right? I hope you understood my. So these are the things. Okay, I have discussed all the case. Okay, one more case is what left. If you allow me hardly to take. Now always remember the fourth one, case 4, that I have to write here. Case 4. What is the case 4? That constant, Raoult's constant, I had shown you that Raoult constant E. If E is what 0, there is no E. Is what 0, then what will happen? E is what 0. Huh? So if E is 0, then what will happen actually? So that time, if E is what 0, remember one root. I will write here. One of one of one of the value of lambda is is 0, then 1 of the lambda will be 0. Okay, that is the 1. Okay, which shows which shows dynamic unstable. This shows one mode is dynamic unstable. Okay. Second point, if if the other roots are negative, other roots are negative, then then it shows pure convergence. Pure convergence. The last is very important. This is first will, if other roots are negative, remember other roots are negative, then it's a pure convergence. If other roots are positive, other roots are positive, then it shows pure divergence. They can ask the convergence and divergence also. Can ask the convergence and divergence also. So always remember these four cases I have given to you, and also next class will be solving numerical based. All right. Next class